statement? Hello? Who will read the statement for me? Nilesh Kadam.
Yes, sir.
Have you noted down that?
Writing, sir.
Hello? Hello? Am I audible?
Yes, sir.
Okay. Have you noted down that statement? Today you have to solve all the things. Okay. Just I'm going to give a hint and you have to use the formulas and you have to solve. Because already we have solved two problems related to this design of lever. Okay. So I'll read the statement. You are now in listening mode only. I don't think that that is good because you should have pen and paper and calculator with you while solving the problem. So don't be ideal. Do you have calculator with you, everybody? Conquer power.
Yes,
Hello?
sir.
Do you
Yes,
have
sir.
calculator with you?
Hello.
Hello, do you have calculator with you?
Yes, sir. I have.
Okay. Everybody please keep that calculator and pen paper with you. Okay. Design a right angle bell crank lever. Now all the levers which we have seen are of straight type. Okay, the first problem which we have seen and second problem which we have seen is related to the straight levers. Now this is a bell crank lever. That means right angle bell crank lever. Again, angle is given as a 90-degree between the two arms of that bell crank. Now this bell crank lever, the horizontal arm is 500 millimeter long and the load of 4.5 kilonewton acts vertically downward through a pin in the fork end of this arm. Okay, I will show the diagram later on. One arm of that horizontal, bell crank lever is horizontal and is 500 millimeter long. And on that arm, vertically downward direction, 4.5 kilonewton force is acting. Okay, fork means that while we are going to connect that bell crank lever, it is connected by means of a fork. Okay, and you know that double I section of knuckle joint, that type of fork is there, and in between that this arm of that bell crank lever is placed. At the end of 150 millimeter long arm, which is perpendicular to 500 millimeter long arm, a force of P act at right angle to the axis of 150 millimeter arm through a pin into a fork end. That means this bell crank lever is connected at two ends, and these two ends are, one is horizontal, other one will be naturally vertical, and the horizontal arm is 500 millimeter long and vertical arm is 150 millimeter long, and both end of this lever are connected by means of a fork type, that is double I type of joint. The lever consists of forged steel material and a pin at the fulcrum. That is fulcrum. Naturally, the fulcrum is at the right angle where the angle is measured at that point. Take the following data for both the pin and lever material. Okay, the arm is, that is lever is made up of forged steel, as well as pin is also made up of forged steel. That's why the material properties are given, and we have to take same material properties for lever as well as for pin. Shape stress in tension, that is sigma T, is equal to 75 megapascal. Shape stress in shear is 60 megapascal, that is tau. Shape bearing pressure is 10 Newton per millimeter square on every pin. Now, read this statement carefully. You'll come to know that there are three pins of this bell crank lever which are connected to the lever. Now see, this is a bell crank lever. One arm of this bell crank lever is 500 millimeter long, where W is attached. Other arm, which is vertical, which is 150 millimeter long, force P is applied, that is effort is applied. And this is a fulcrum point. So we are going to give name as a B, F, A or A, F, B. This is what the lever is. Okay. And we are going to consider that B is the width of this lever and T is the thickness of this lever. Okay. This cross section is shown in this diagram. Do you get the idea how the bell crank lever is? Any question? Now, when we are going to start to solve this problem, it is given that FB, that is F to B distance is 500 millimeter. Then W, which is at point B, which is equal to 4.5 kilonewton, that is 4,500 Newton. F to A distance, that is the fulcrum point to this point where P is applied, is 150 millimeter. Then sigma T, that is allowable tensile stress, is 75 megapascal, that is 75 Newton per millimeter square. Allowable shear stress tau is equal to 60 megapascal, that is 60 Newton per millimeter square. And bearing pressure is 10 Newton per millimeter square. Okay. So first of all, what we have to calculate?
Value of P, sir.
Value of P. Pressure. Hello. Yes, you are right.
Yes, sir.
Value of P. P. What the P means?
That force, sir.
Right. Force which is applied at the point A. Right. Because W is known, and we have to calculate P. Now, how we can calculate P? So start solving this problem. First of all, let us find the effort P required to rise the load W. Okay, taking movement at the fulcrum F. If we are going to take this movement at point F, then this W is creating clockwise movement, that is W multiplied by 500, and P, which is creating anti-clockwise movement, that is P multiplied by 150 millimeter. That's why at fulcrum we are going to consider that the summation of all movements equal to 0. That's why this anti-clockwise movement will be at one side of the equality and this clockwise movement will be at other side. So this is the movement. W multiplied by 500 is equal to P multiplied by 150. So can you calculate that P? Just tell me what the value of P is by calculating.
15 kilonewton.
15 kilonewton.
Huh.
Okay. Now here we are going to convert this kilonewton into Newton. So don't use that kilonewton unit. Use as a Newton as well as millimeters. Okay. If you are going to measure the length, it will be in millimeter. And if you are going to measure the force, it will be in Newton. Anybody else? What answer you have got?
15 kilonewton, sir.
15 kilonewton.
Yes, sir.
Okay, very good. Last two. आदेश बनकर. हेलो आदेश बनकर. ऋतिक भोसले. May I know where the Ritik Bhosle is? Ritik Bhosle. Can you unmute yourself or just type your message? Are you listening me, Ritik Bhosle? Hello? Saurabh Dhotre.
Yes, sir.
What answer you got?
Sir, continue.
What?
Sala, sir. 2 minutes.
Calculating, not continue. Continue means you are giving order to the person who is talking with you that continue. Okay, anybody else? Suraj Gowri,
Sir, 15 kilonewton. 1 5.
15 Newton, right. Suraj Gowri. What answer you got, Suraj? Are you there? Hello? So you have got 15 kilonewton as the answer. P is equal to W multiplied by 500 divided by 150, and W we have already calculated, and that is equal to 4,500. That's why we have got this 15,000 Newton as a P. Now we have to calculate reaction at fulcrum. How we are going to calculate the reaction? That you know.
15.66 kilonewton.
That is the reaction. Am I right? Hello?
Yes, sir.
Yes.
Yes, sir.
Yes. So REF, that is reaction at point of fulcrum, that here you are going to calculate. So that you are going to calculate by means of this vector and this vector. Its resultant will be W square plus P square will be whole in the under root, right? So we are going to get that reaction, that is REF is equal to under root W square plus P square, and that we are going to get as a reaction at fulcrum point. And once you got this reaction at fulcrum point, then let's start to design this point P. So fulcrum pin we are going to design. First of all, the pin which is joined at fulcrum, that we are going to design. So for that, let us consider that small d is the diameter of fulcrum pin and L is the length of this fulcrum pin. And if you are remembering what ratio we have taken for the for length to diameter of this pin. Are you remembering? For yesterday's problem also we have taken that ratio. Hello? Hello? We are going to consider that the length of pin is 1.25 times of the diameter. Okay. We have solved yesterday's problem also by assuming length of pin equal to 1.25 times of the diameter of that pin.
Yes, sir.
Now, yes, right. Now this fulcrum pin is undergoing to the bearing and it is sustaining bearing pressure. Am I right? So bearing pressure, which we are going to consider, that bearing pressure is generated by means of what? Load on that pin. Am I right? So at fulcrum, how much load is coming on that pin? at fulcrum point, what load is coming on that pin? Definitely it will be the REF. Am I right? Hello?
Yes, sir.
Yes, sir.
Yes. And it will be sustained by what? Area multiplied by intensity of pressure, which we have seen for the last problem. Am I right?
Yes,
Are you
sir.
getting this point or not?
Yes, sir.
Or should I elaborate it? Should I elaborate?
Yes, sir.
Okay, I'll write here this formula by means of which we are going to calculate the pressure intensity. So this pressure intensity P suffix B we are going to calculate. This pressure intensity P suffix B is given by, how we are going to calculate pressure intensity? Hello? Force divided by what? Is it right? I'd like to hear from you.
Yes, sir.
Is it right? Pressure is equal to
Yes, sir.
force divided by area. Right? So force which is coming on the fulcrum pin is what? 15,660 divided by what is the area of that pin? Now as it is circular area, we are going to convert it into flat area. Am I right? For yesterday's problem we have solved it. So area will be D into its length, L. Is it right? Hello?
Yes, sir. Yes, sir.
Yeah.
Yes, sir. Yes.
Okay. So what we have done for this formula we have converted just to I want to write it in form of force. So what I have to write? Force is equal to what? Pressure intensity multiplied by area. Is it right? That is,
Yes, sir.
yeah. That is, here I am going to write this P suffix B multiplied by area. And area is what? Sorry, this D into L is coming in at this point. Here I want it. D into L. It will be D it will be D into L, right? So this pressure intensity formula we have written as a force divided by area. Force is 15,660 divided by area is D into L of that pin. So how that D into L again we have taken? Just I will draw here that pin. This is what the pin which is inserted there. Okay. So what we are going to calculate area of this pin, and this area is calculated as this distance multiplied by this distance. Is it right? That is the length of pin multiplied by diameter of that pin, and that will become the cross sectional area of that pin. though it is circular one. This is the circular area which is sustaining that pressure. We are going to consider it as a flat approximation we have done here, and we have considered it as a flat area. Is it right? Hello?
Yes, sir.
Okay. If you are not getting it, please let me know. You can ask question at that place only. So our motto is to calculate diameter of this pin, this diameter. And this is length. So already we have decided that what we have taken for the diameter as well as for the length. So diameter times 1.25 times the length is of that diameter. That's why we are going to put this value of L as a 1.25 of D. And hence we are going to get this W, that is 15,660, is equal to D, that is diameter of pin, multiplied by 1.25 of D. Is it right? Into intensity of pressure. Intensity of pressure is given as a 10 Newton per millimeter square. So we have got this W is equal to, I'll write here separate equation, that will be fine, is 15,660 is equal to 12.5 into D square. From the above equation, we have got this equation. Am I right? So one can calculate this D. So what value of D you have got? Your calculation. Hello?
35.3.
25.3.
35.3.
35.
हाँ
35.13.
9.
39. Okay. Here you are getting this as a 39. Right? So we'll approximate it to the 36 millimeter. And from this, we are going to calculate length. Because length is how much? Hello? Length is 1.25 times of D. That's why length of this pin is 45 millimeter. Is there any question related to this up till now?
No.
Any one of you? Yes, sir. Hello?
No, sir.
You have got it?
Yes, yes.
Okay. Rohit. Rohit Chatge. Hello? Nana Sahib Shinde. Are you there? Nana Sahib Shinde. Saurabh Wadekar.
Yes, sir. No, I will understand.
You understood all. Bagal. Sandeep Bagal. Bagul, it is Bagul, not Bagal.
yes sir, understood.
Okay. Akash Mane.
Understood, sir.
Okay. Omkar Kale.
No sir, question any.
No any question. Okay. Vaibhav Jagtap.
येस सर समजलं सर.
समजलं. सुमित पटवारी.
Got it, sir.
हा, समजले?
Yes, sir.
ओके, ओंकार योग. Then where this? Yes, sir.
Yes,
Are you
sir.
there?
Yes.
Have understood it?
Yes, sir.
Okay,
Sir,
you have not
hello.
given reply. हा बोला.
ते आपण अजून केले ना लेंथ एल इज इक्वल टू 1.25D.
हा हा हा.
मग तिथल्या व्हॅल्यू जर चेंज केल्या तर आन्सर वेगळे येणार ना.
लेंथ जर चेंज केली तर का?
हा, ते अज्युमिंग आपण केलेलं लेंथ इज इक्वल टू 1.25D.
बरोबर आहे, वेगळी व्हॅल्यू येणार ऑब्व्हियसली. त्याच्यासाठी आता पुढचा पॉईंट आहे, मागच्या गणितात आठवतोय का बघा तुम्हाला, की आपण डबल शेअर मध्ये ती पिन टिकत्या का नाही बघितलं होतं.
हा हा, येस सर.
आता जे पिनचे डायमेन्शन काढलेत आपण, डायमीटर इक्वल टू 36 मिलीमीटर, लेंथ इक्वल टू 45 मिलीमीटर, that we are going to check whether it is going to sustain that shear stress or not. And if it is sustaining, that is shear stress is within the limit, then we are going to use that same dimension. If not, we are going to change it.
येस सर, येस सर.
Got it? So
Got
once
it.
again I am calling, yes. Once I am calling to whom? Who has not given answer? Just a minute. सूरज गौड़ी, आदेश बनकर and Aniket Bhosle.
Got it, sir.
What is Adesh Bankar? Are you there? Pratik Deshmukh. Hello? Pratik Deshmukh. Saurabh Dhotre. Pratik Deshmukh, yes sir, he has got, he has given. What about Saurabh Dhotre?
Yes, sir.
Will you unmute? Yeah. Hello? Yes, Saurabh Dhotre. I'm not listening you actually.
Got it, sir.
Got it? Okay. So next point is that you have to check this pin in shear. So what will happen in case of shear? What formula you have to write? Yes. First of all, you tell me what formula you are going to write for the considering shear stresses in this pin. It will undergo to double shear. Am I right? Okay. So what formula we can write? Shear stress is equal to. Yes.
Force per unit area.
Force per unit area. Stress is equal to force divided by sustaining area. Am I right?
Correct.
Yes, sir.
Okay. So what we can write next? How much force is acting on it?
Fulcrum reaction.
Fulcrum reaction, RF, right? So we have to write here as R suffix F. So fulcrum reaction divided by what will be the area? Now this pin will undergo to the double shear. So area will be get multiplied by 2. Am I right? This will be sheared at 2 places. Okay. What the area will be? 2 into
5 by 4.
pardon? Hello? 2 into 5 by 4.
D
And
square.
what will be D? That is diameter of pin. Square. Am I right?
Yes, sir.
So when we are going to write this formulae, just you have to calculate what is the value of tau. This shear stress is nothing but we are going to write it as a tau. You tell me, you calculate and tell me what the value of tau you are getting. Later on, I will put my answer.
Sir, 7.69
7.69. Anybody else?
Newton per
Because
inch.
RF is known, D is known. Just we have to calculate tau.
7.66.
Same, sir. 7.69.
7.61. Okay, 7.69. Pratik Deshmukh, you put your just message what value you are getting. Vaibhav More has written as 7.69. Ekatpure, what value you are getting? Hello? Prerna Ekatpure, are you there? Snehal Mane. Prerna Ekatpure has written as a, okay, 7.69. So you have got the 7. Yes? You have got 7.69 as a value. It is approximated to 7.7. And what value is given in the problem for shear stress? What limiting value is given for the shear stress in problem? How much it is?
60.
MPa, sir.
Right? So can we say that dimensions which we have decided for the pin are safe?
Yes, sir.
Yes, that's why not necessary to go again. Somebody has asked me question that what will happen if we are going to consider other type of relation, that is if L is equal to 1.30 of D or if L is equal to 1.50 of that D, we'll get different answer. Okay, but not necessary to go for considering that different value. Now see, this length is equal to 1.25 of D. That is the standard one which we have chosen from design data book, where is the guidelines which are provided to the designer to make design simple. Okay. Any question? So can we go further?
Yes, sir.
Okay. One more question I would like to ask, whether this method is good. I'm going to type here and you are getting it.
Yes, sir. Yes.
Yes, yes.
Okay, instead of only reading that slide and explaining it, if I'm going to write here and if I can make the change, that will be better. Is it right?
Yes, sir.
Yes, sir.
Okay, okay. Now we have designed pin at fulcrum. Now we are going to design a brass bush which we are going to insert in that hole which is provided for the fulcrum or fulcrum pin. Now here let us assume that the thickness of this brass bush is 3 millimeter. What thickness we have chosen for the last problem? Are you remembering? How
2,
many?
sir.
It was 2. Okay, here I have chosen as a
2.
3. Yes, yes, yes. So is it random that we can choose the thickness, or just we are going to have some logic behind that? So let me tell you one thing. This thickness of bush is decided as from 2 millimeter to 5 millimeter. That already in first lecture, when we have started this design of lever, that statement was there. From design data book, it has been stated that bush thickness is ranging from 2 millimeter to 5 millimeter. So here we have chosen as a 3 millimeter. One can go for 2 also. One can go for 4. That is depend upon how much force is exerted on that bush. His force is measurably high. How much it is? 15,660 Newton. That is the force, fulcrum reaction, which is acting on the pin as well as on bush. That's why we have chosen thickness of this bush as a 3 millimeter. So the hole which we are going to drill on that lever, that bell crank lever, will be of size D plus 2 times of thickness from this side and from this side. Right? So it will be 36 plus 6, and this drill will be of 42 millimeter. Once you have got this drill, then we are going to calculate how much that added thickness will be there and what will be the diameter of that. Already we have calculated the length of pin is equal to 45 millimeter and thickness is increased in the lever by means of this 2 times of the D, that is the 2 into 36, that is 72 millimeter. Are you remembering? Hello?
Yes, sir.
Okay. So 72 millimeter circle will be there where the thickness of that lever will get increased by means of thickness of this bush. Okay. Is there any question for this slide? Any question?
हॅलो
Yes.
सर
Yes.
ते थिकनेस बद्दल सांगा ना परत.
थिकनेस बद्दल सांगू का?
थिकनेस
Okay.
व्हॅल्यू कशी घेतो?
सांगतो. Just a minute. This is bell crank lever. Okay. This pin. Okay. Thickness. This thickness that we are going to increase by means of, here we are going to have okay. Now this 45 millimeter is nothing but the length of the pin which we are going to insert here. But as we are going to get this thickness which we have to increase, and above which we are going to have one rectangle which will indicate as a lever. Okay. Are you getting this? Now there are three rectangles. One rectangle is related to the length of this pin. Okay. This red one is indicating as increased thickness of this lever, and this black rectangle is related to the actual lever, where we have considered the cross section of that lever. And this thickness is increased to compensate that hole which we have provided inside that solid lever. See, this rectangle T and B is nothing but that black rectangle which we have considered here. And this red rectangle is nothing but the thickness which we have increased for inserting this pin and this bush inside this lever. Have you got it? Hello?
Yes, sir. Yes, sir.
Okay. Any other question? Hello? Any other question? If not, then we are going to consider that the pin which we are going to insert at fulcrum point, same pin will be used for the pin at point A and at point B also. Okay, so pin which we are going to insert at point A, so where the point A is. For that, we will see once again this diagram. Now this point A, where the pin is inserted, same dimension of that pin which we have calculated at F point will be used here. Okay. And now we have to calculate the pin which we can insert at point B. So in this slide, it has been written that the effort at point B, F and A are not differ much more. It is 15,000, and that F which we have got is 15,660. That's why same dimensions of pin are used at point A also. So you can mention in actual, while you are solving problem in exam, you can mention that effort is not much more than the reaction at fulcrum. That's why same dimension. And again, if the effort will be higher than the force which we have considered at point F, then you have to go for redesigning. I'll repeat it. जर आपल्याला फल्क्रम पॉइंटची रिएक्शन REF जी कॅल्क्युलेट केली आहे, जी आहे 15,660 न्यूटन, ह्याच्यापेक्षा जर A पॉइंटवर अप्लाय केलेला फोर्स जो P आहे तो जर जास्त असता तर ह्या पिनचे डायमेन्शन आपण वापरले नसते. आपण परत एकदा बेरिंग प्रेशर, डबल शियर कन्सिडर करून त्या पिनचे डायमेन्शन कॅल्क्युलेट केले असते, जसे आता कॅल्क्युलेट केले तसे. पण P, that is the effort which we have applied at point A, are less than the REF, that is reaction which we are getting at fulcrum. ती आहे 15,000 न्यूटन आपण P वापरलेला at point A, आणि रिएक्शन ऍट एफर्ट आहे 15,660. मग जर 15,660 न्यूटनला एखादी पिन आपण डिझाईन केली आणि ती 15,660 न्यूटन लोड घेत असेल तर 15,000 न्यूटन आरामात लोड घेईल ती, कारण त्यापेक्षा जास्त लोड घेते. 660 न्यूटन जास्त लोड आहे, त्याच्यामुळे तीच डायमेन्शन्स आपल्याला चालतील. गॉट इट?
Yes.
एनी क्वेश्चन? आर यू गेटिंग इट और नॉट? Hello? Please
Yes, sir.
reply me. Okay. Now we are going to calculate dimensions of pin at point B. आता ह्या पॉइंट बी ला आपण तीच डायमेन्शन घेतली तर चालतील का? सिंपल क्वेश्चन आहे. जिथे आपल्याला लोड W is acting and reaction at fulcrum we are getting as a 15,660. How much W is? W किती आहे?
4500.
4500.
4500.
राईट. पण तीच डायमेन्शन घेतली तर चालतील
No, sir.
का बरं? 15,660 ला जर टिकत असेल तर 4,500 ला टिकायला पाहिजे किती?
Sir, cost वाढणार
राईट,
नाही.
कारण तिथं डायमेन्शन्स खूप जास्त घेतलेत
नाही,
आपण आणि अननेसेसरली मटेरियल तिथं जास्त जाईल मग. बरोबर आहे. पिन होईल तिथं, म्हणजे एकदम मजबूत पिन होईल तिथं, पण तेवढी गरज नाही. दॅट्स वाय अननेसेसरली कॉस्ट विल गेट इन्क्रीज. राईट. सो वी हॅव टू कॅल्क्युलेट द डायमेन्शन्स ऑफ पिन विच वी आर गोइंग टू यूज ॲट पॉइंट बी. परत एकदा बघा. त्या बी पॉइंट वर ऍक्ट होणारा जो फोर्स आहे दॅट इज डब्ल्यू, विच इज व्हेरी लेस ऍज कम्पेअर्ड टू द फोर्स विच इज ऍक्टिंग ऍट पॉइंट एफ अँड ए. एफ आणि ए मधला फरक फक्त 660 न्यूटन होता, पण एफ आणि बी ह्याच्यामधला फरक किती आहे? 15,660 वजा 4,500. ओके, जवळजवळ 11,000 न्यूटनचा. दॅट्स वाय इफ वी आर गोइंग टू यूज सेम डायमेन्शन ऍट पॉइंट बी, पिन खूपच स्ट्रॉंग होईल तिथली, आणि तेवढी स्ट्रॉंग पिनची गरज नाही. अननेसेसरली मटेरियल वेस्ट जाईल, अननेसेसरली कॉस्टिंग वाढेल. सो वी आर गोइंग टू डिझाईन dimensions of pin which we are going to use at point B. Then same procedure. First of all, what we have to do? We have to consider bearing pressure, and from bearing pressure we have to calculate same formula. I will copy it from here. Shear stress, not shear stress. I require this dimension. Is it right? Intensity of pressure is equal to force divided by area. So intensity of pressure is equal to force. How much force it is? 4,500. Right? D. Now here we have considered D suffix 1 as a diameter of pin which we are going to use at point B, and L suffix 1 as a length of that pin which we are going to use at point B. So here I have to change it and I have to write it as a D suffix 1 instead of writing D. And this L also I have to replace by means of L suffix 1. Okay. This D also I have to replace by means of D suffix 1. Do the calculation meanwhile. I'm going to write it, but you please do the calculation what D and L you are getting.
19.
19.
D1, 19.
We are getting D1 as a 19. And what L?
24.
24.
24.
Okay, anybody else? If you have done calculation, please tell me.
Same, sir.
Same. Okay. You can write in comment box also. The other people, those who are doing the calculation. Like Dikshit. Manthan Dikshit.
Yes, sir.
What value you have got for D1 and L1?
Same, sir.
I want a value. Same means what?
19 and 25.
19 and 25 millimeter. Okay. Anybody else? अजून कोणी कॅल्क्युलेट केले का? So value which we are going to get for D1 is 19 millimeter, that is 18.97, approximated it as a 20 millimeter. You have approximated it to the 19 millimeter, no problem. Okay. And L1, that is the length of that pin, you have approximated to the 25 millimeter. Okay. Now, as per this slide, is there any question? Hello?
No.
No any question. Okay. Can we go further? If you have any question, you are free to ask. Now this pin has to be checked for shear stress. Am I right? Hello? So how you can check it for shear stress? Can you calculate value of shear stress? What shear stress is? Shear stress is equal to force divided by area which is undergoing for the shear stress. So force which is acting, that is how much? W divided by 2 into pi. What I have to write here?
D1.
D1. So D suffix 1. Now you know that W is how much? 4,500. D you have calculated 20. You take 20 as a D1 and calculate value of tau, and you just tell me what the value of tau you are getting.
7.16.
7.16. Okay, 16. Anybody else? अजून कोणी calculate केले का?
7.16.
7.16. Yes, it is 7.16 Newton per millimeter square. Okay. So we have got this value, and whether this pin is safe now in shear stress, what value, limiting value is provided for the shear stress? Yes,
Yes, sir, it is safe.
it is safe. Why? Because limiting value of shear stress is 60 megapascal, whereas the induced stress is 7.16 megapascal. That's why definitely this stress will not exceed by this pin or dimensions of this pin. Hence, this pin is safe. Now we have designed pin at point F, we have designed pin at point A, we have designed pin at point B. Now what is remaining? Hello? What is remaining? Now we have to calculate, or we have to design lever. Before that, we have to design bush which we are going to provide at point B. So this bush is provided of thickness 2, okay, or same bush of thickness 3 we can take here. So bush inner diameter will be, or diameter of that bush will be D1 pin diameter plus 2 into thickness of that bush. Should I write here once again, bush? Am I right? So the hole which we have to provide on the bell crank lever is of 26 millimeter, and also the added thickness, that is, we have written it as a capital D. It is 2 times of the diameter of pin, and that is equal to 40 millimeter. Okay. So we have calculated this bush dimensions. I will take this first and later on we'll go for the designing of that lever. Before that, just we have to check whether the bending stress which has induced in the pin is able to sustain that bending stress or not. So for that, we are going to consider this as a bending moment of the pin which has inserted. Okay. So that pin which has inserted at point B, which is sustaining load W. Now this pin which is inside the lever has a length equal to this L1. We'll consider this thickness of the fork in which the pin is inserted, that is equal to T1, and this T1 is calculated as L by 2, that is standard formulae which we have taken from design data book or from design data book. Okay, there is no any other way, or we can have that, we can calculate shear and all that stresses which are induced in this fork, and we can take it, but the thumb rule is that thickness of this fulcrum or this fork, that can be taken as a half of the length of that pin. Okay, or length which we have considered inside the bush. Are you getting me or not? Now here, this is going to provide load W in upward direction. So this much part will be undergo to the W by 2 force, and remaining this part will undergo to the force which is acting in upward direction as W by 2. Now, same way, the pin is subjected to the downward load because it is providing reaction, and that is equal to W. Yes? Any question? If not, this W by 2 is sustained by the half part from this YY section, and W by 2 is sustained by remaining half part of this bush. Okay, that's why here we have drawn this as a bending moment diagram. Okay, actually this is shear force diagram, not bending moment. This is shear force diagram. We have to choose where the shear that bending moment will be maximum. So this is the point where the bending moment is maximum, where I have put the cursor. Is it right? Am I right? Hello? So half part of this pin is considered under bending, and just we have to calculate bending moment M, and this bending moment will be equal to W by 2 into its length, this length. Okay, and that length is equal to L by 4 because L by 2 is at YY section, and again we are going to make half of that. That's why it will be L by 4. Okay, and that bending moment we are going to calculate here. That is W by 2, which is sustained by at length L by 2 plus T1 by 3, that is nothing but the thickness of that fork at T1 by 3 because it is uniformly gradually increasing load. Okay, and this triangular load which we have considered has a point where it will be acting as a point load at 1/3 of the distance from zero load, or 2/3 of the distance from highest load. So this T1 by 3, this is the length where this point load is acting, and L1 by 2 where this point load is acting, and that load is equal to W by 2. So force multiplied by distance, that you are going to calculate as a movement, minus the reactive force, that is nothing but, again we'll see this diagram. Should I explain it once again? Hello?
Yes, sir.
Okay.
Yes, sir.
Okay. So we'll take movement at YY section. Are you agree with me? YY section means बरोबर सेंटरला त्या पिनच्या तिथं आपण एका साइडची बेंडिंग मुवमेंट घेऊया, दुसऱ्या साइडला सेमच असणार आहे तशी. बरोबर आहे का? हॅलो?
Yes, sir.
हा, असं मध्ये सांगत जाऊ मला. बरोबर. हा, आता हा जो आहे मी इथं ड्रॉ करतो as a cantilever, one single lever. Okay, I'm going to take movement at this point where I can insert this point. This I'll call it as a O. Okay. Now this W by 2 is acting. This W by 2 is acting somewhere here in downward direction. Okay, what is the length where this W by 2 is acting from point O? O पासूनची लेंथ किती आहे त्याची? Hello? Are you with me or not? Length किती आहे? And how much load is acting here? That is in downward direction as a W by 2. हा लोड आहे तो W by 2 आहे. W by 2. Okay. So what this is this length, how much it is? कोण सांगताय का? ही किती लेंथ आहे ही? त्या सेंटर पासूनची ह्या W/2 हा खाली आलेला W/2 किती असणार? L1/4, right?
L1/4.
So this distance is L1/4. L1/4. This L is small.
सर सर टाइम ओव्हर झाले त्यामुळे काय समजणार.
होय काय?
सर बात करा सर.
ओके ठीक आहे. We'll see it to the next lecture. This remaining part.
Yes, sir. Yes.
हाँ ठीक है सर.
Okay, no problem.
Yes, sir.
Actually, we required 2 hours to complete this. Okay, I'll take presenting. Then stop sharing and stop recording.